Welcome to my presentation. In this presentation, we shall see the procedure to solve system of linear equations. There are several procedures to solve system of linear equations. One of the procedures we will see in more detail in this particular in one of these presentations is the Gaussian elimination method with back substitution. Let me first explain the procedure for solving system of linear equations using the row echelon process. Let us write them down in these different steps, and then we will try to solve some problems based on this procedure. Step number 1. We want to write the augmented matrix of the system of linear equations. When a system of linear equations is given to us, we want to be able to write the augmented matrix from that. So let me write this one as from system system of linear equations. We want to write the augmented matrix. And then we want to use the elementary row operations like we talked about, and I'm going to write that as step number 2. We want to use the row operations to rewrite the augmented matrix in row echelon form. So the way I want to write this one out is we want to use row operations to rewrite the augmented matrix in row echelon form, and we talked about that in one of our presentations, but we'll explain that some more, and that is as follows. If we have a system of linear equations in two variables, it's going the row echelon form should look like this: 1a b 0 1 c, and if we were to put brackets around that and separate the constant numbers by a vertical line, we should have ones along the diagonal and zeros below the diagonal, and that is the desired form of the row echelon form for a system of linear equations in two variables. So that is step 2. Or if we have a system of linear equations in three variables, then the row echelon form, the desired form of row echelon form should look like this: 1a b c 0 1 d e, and then 0 0 1 f. So this is the matrix, and if I were to partition this by this vertical line, the numbers along the main diagonal are all ones, and the numbers below the diagonal are all zeros, and this is the desired form for a system of linear. This is the desired row echelon form for the system of linear equations in three variables. Okay, and we will use these methods. We'll use this row operations procedure to solve system of linear equations using using Gaussian elimination method. There are several methods, but Gaussian elimination method is one very commonly used method in matrices. In my next presentation, we shall see how to solve system of linear equations using the Gaussian elimination method with back substitution.